Hey guys, and welcome back to 2 Minute Coder. So today we're doing Leetcode problem 155, which is min stack. So this is kind of different from the questions we've done in the past because instead of an algorithm, this is designing a class. So we have a class called min stack, and we have instructions on what each function should do. So this is basically just so you can get a better understanding of how a stack works under the hood. So let's look at some of the constraints. So the constraints we have here is that the pop, top, and get min operations will always be called on non-empty stacks. So we don't have to worry about null errors in that. Also, we have to implement a solution with constant time complexity for each of the functions. Okay, so let's get into it. Min stack initializes the stack object. Okay, so when this is called, the object needs to be initialized. Okay, so outside of each function, let's start by declaring two stacks. So stack integer, call it our stack. And for this solution, we're going to have two stacks. Actually, we're going to have a normal stack that will do the pop function, the top function, and we'll also push into our stack, obviously. But for this get min function, where we have to retrieve the element, the minimum element in the stack, because we have to do it in constant time complexity, we can't go through our stack and put the minimum element at the top and then pop. So we have to at all times keep track of what the minimum element is. So we'll do that with the help of a second stack. Okay, and you guys will understand it more if you're not understanding it now when I get to that function. So for initialization, so our stack is going to equal a new stack. Right, so every time this min stack function is called, these two predefined or declared variables are going to be instantiated. Right, new stack. All right, so let's do pop first. So this is a normal pop from our stack, right? And because we are keeping track of two stacks, we will also have to pop from the second stack as well, right? Because, for example, if we encounter the minimum element and we want to pop that, not only will we keep track of that minimum element in stack, but it will also be put into min stack. So in both stacks we have to pop. Okay, and notice how this is a void, so we don't actually have to return anything, but because the return type for top is int, we do have to return an integer. So what does the top say? Gets the top element of the stack. Okay, so we're not going to be returning from the min stack because this is only specifically for minimum elements. We will be returning from stack because that's the stack that we are sorry, voice crack. That is the stack that we are keeping track of for all elements. Right, so instead of the pop function, we're going to use peek, because that lets us know what the top element of that stack is without actually popping it. Okay, now before we can go to our get min, actually let's do get min. Alright, so it's going to be pretty simple. This is the only function that we will use or retrieve from our min stack. Okay, so we know to return from this min stack, right? Because our stack is just going to be keeping track of all the elements, but the minimum elements will be kept track of in min stack. Now, how will we keep track of the min stack elements? we'll see that in push. So first, obviously, all values will be pushed on to our stack, right? Now, how do we know what goes into min stack? First, what we have to do is evaluate what is a minimum element between this value that we have passed and the values that are inside stack. Okay, values or value inside min stack, sorry. Right? So we can use the math.min function and compare this value. But we also have to see what is in our min stack previously. Because if our min stack contains, for example, 2 and our value is 3, then we know not to take this value, right? We should just leave the min stack as is. Okay, so first let's check if it's empty. Okay, and we can use the ternary operator, which basically just says that if this condition returns true, return this or execute this, and if not, then execute this. Right, so for you to better visualize it, there can be a condition and then true, false, right? So this is the condition, and if this condition is true, it will execute this, and if it is false, it will execute this. So basically what this is saying is we have our value, okay, but we want this value, which is going to be pushed in to our min stack, to be the minimum between the value passed and if the stack is not empty, what is that value? Okay, and if it is empty, then obviously it's going to be this value, but because we have to put something in this section, then we will just add that value again because it's just going to be the same thing, right? Yeah, I think that's it. Let's run it. Yeah, perfect. So don't look too much at the runtime. See, if I submit it again, then this is just going to change. Well, that did not change, but okay, let me just like show you this solution. Okay, so it did not say, yeah, see, look at this. This is the exact same code, okay, exact same code, and instead of our runtime being 5 milliseconds, it's 4 milliseconds, and our memory is also better, our runtime is better. So, you know, when you guys are submitting these functions or you're doing algorithms, you really need to evaluate for yourself how fast it's going to be, like if it's using constant memory or linear memory or exponential, or what time complexity is, because most of the time when you submit it on Leetcode, the response time and all can, you know, get a little wonky and stuff. So yeah, hope you guys understood this. If you didn't, let me just explain it once again. Okay, so in our min stack, we need to keep track of the minimum value, right? So we need to evaluate what is the minimum value between this value passed and any possible values that might be in min stack. Okay, it can be one value, it can be two values, because like if we see 1 twice, right, then we're gonna have 1 1 in that min stack, right? It's going to be the same value, but how many times it can occur, like, we don't know. But this min stack dot peak is going to take the top of that element, right? So don't misunderstand it in the way that our min stack will only have one value in it. No, you can have as O of n memory complexity, because if we are given an input array of just zeros, then all of those zeros are going to go into min stack, right? So evaluate what is the top element in our min stack against this passed value, and whatever is the minimum of that, push that onto the min stack. If the min stack is empty, then we just pass the same value, right? So we don't get a null error. Right, so hope you guys enjoyed. This was kind of different from the problems that I've done before. But yeah, hope you guys enjoyed it, and subscribe for more.